Hello friends, welcome to this video, and in this video we are going to work with matrices in TensorFlow. So basically a matrix is just a two-dimensional array like the one you can see in this figure. So why it is important to understand the matrices basically. Understanding how TensorFlow work with matrices is really important, as working with neural network involve a lot of matrix operation and many algorithms depend upon these matrix operation only. Okay, so it's really important to understand matrix operation, because everything in machine learning is just a kind of, it just represented in the form of some matrix. Okay, the one you can say is image is also matrix. The language model, that is the words in the language, are represented as first they are represented as one hot, then we have embeddings. So everything is just a, basically you can say, is a matrix. So understanding matrix operation is really important. So here we are going to learn how to create matrices and perform some basic operation on them. Okay, so let's first create a session and then we are going to create matrices. So we can create two-dimensional matrix from numpy array or nested list, or we can use TensorFlow functions such as zeros, ones, truncated, normal, etc, etc. Okay, TensorFlow also allows to create a diagonal matrix from a one-dimensional array or list with the function diag. Okay, now first of all we will create a identity matrix. Use the function diag, tf.diag. now the value here 1.0, 2.0 and 3.0. okay, let's create some more tensor here. Truncated normal. First a shape 2/3, or you can write it like this: shape. It also has data type, the type of data type float 32. okay, we can create another like tf dot random uniform. Shape should be equal to 3/2. okay, this time 3/2, and the data type same as the above, tf.float 32. spelling mistakes. Let's create another tf.fill. now shape 3/3 and the value 5.0. so what fill does is fill this 3/3 matrix with a value 5. now let's create a matrix, that is a tensor, from a numpy array using the convert to tensor function. now I'm going to write a numpy array. Let's make them float. okay, so like this you can create. So now we'll print each of them and see their value. okay, print session dot run identity matrix. let me copy this. Print a here, then B, then C, and the last one D, and see the result. So first of all we have a diagonal matrix like this. We have specified one here, 1, 2 and 3. so it has created a 3/3 matrix. the size of the value is we have 3 values here, so it has created a diagonal matrix of 3/3. next we have the truncated normal 2/3 and then a 3/2 random uniform. Next you can see a fill, a 3/3 fill. and at last it can see a numpy array converted to a tensor. Now we are going to perform some basic operation on them. First we are going to perform an addition. So first, one condition for addition and subtraction both is applied, that the dimension of both the first variable and the second variable on which the operation is performed must remain the same. That is, if A has a shape of 3 by 3, then B must also be have a shape of 3 by 3, otherwise there will be an error. See, A plus A, simple. If we have A plus B, I think both have different, both have different shape. You can see error because the shape dimension must be equal. So A plus A is good. Now same, let's do this with C, fill C minus C. Okay, again answer 0, both values are same. Now if we do A minus C, again invalid augmentation error because of the shape 2 by 3. Now no problem. Okay, so you need to just check the dimension on this operation first. The next is the matrix multiplication. In case of matrix multiplication, you need to remember some rules. Just see this figure, this is matrix multiplication, this is matrix A, this is matrix B, and this is the matrix after the dot product, that is the matrix multiplication. The resultant matrix will be this. So the shape or the dimension of the matrix A is 2 by 3, let's say M1 and N1, and the dimension or the shape of matrix B is 3 by 2, and let's say them M2 and N2. So for matrix multiplication, N1 must be equal to M2. Okay, so the N1 must be equal to M2, remember that, this is really important. And the output matrix, that is this resultant matrix after the operation, will be the M1 and N2. Okay, now we'll see this operation here. Function for matrix multiplication, tf dot matmul. Okay, so let's check the correct shape. B and C, A and B, A and B. Okay, A and B, first variable A and B. So you can see A has a shape of 2 by 3, B has a shape of 3 by 2, and the output is 2 by 2. See here. But if we change the shape, like we multiply A and A only, so you can see invalid augment error because of the dimensions only. So for matrix multiplication, you need to provide the correct dimension. Just remember that. Now let's find out the transpose of a matrix. I have already copied this. You just need to write a function tf dot transpose. Let's write the last one here, the D. Let's print the D before the operation also. So you can see D before operation is 1, 2, 3, 4, 5, 6 and 6, 8, 9. What transpose does is it inverses the row, interchanges the row into column. Now we have 1, 2, 3 as first row, 4, 5, 6 as second row, and 6, 8, 9 as third row, third column, not rows, column. So that's how you can find the transpose of a matrix. Now about the determinant. Okay, we need to find the determinant. So let's choose a tensor. Let's run this 1D. I haven't write the function, just directly writing it. The function is tf dot matrix determinant, matrix underscore determinant. D. So you can see the determinant of the matrix T is 2.9999 till 9998. Now we'll see how to find the inverse of the matrix. why I'm writing this line. The function is tf dot matrix underscore inverse. Let's write D here. So you can see we have matrix inverse here. This is the inverse of the matrix T. Okay, and the matrix T is this 1 2 3 4 5 6. There you can see this. So these are the basic matrix operations you need to understand. Okay, there are much more about matrix, but you need to understand this only. These are the basics of the matrix. Okay, if you like this video, then hit the like button, share it with your friend, and subscribe to my channel, and also hit that bell icon for the future videos. Thank you. Have a nice day.